Good morning, dear students. We'll see the problems on Stokes theorem. Evaluate integration of xy into dx plus xy square of dy by Stokes theorem, where C is the square in the xy plane with vertices 1, 0, -1, 0, 0, 1 and 0, -1. So as we know that, so this is they have given integration over C xy into dx plus xy square into dy. It is given here. Now we have Stokes theorem. So what is Stokes theorem? It is integration over C vector f dot dr is nothing but double integration over the surface S del cross vector f, that is curl of vector f dot n cap ds. To simplify this, here we needed what is vector f dot dr, because here we are going to apply what is vector f. So from this we have to extract vector f. So from the given integral, so from the given integral we can write vector f as xy of I plus xy square of j. So no dz, so therefore 0. So this dx and dy can be written as what here, vector dr, which is dxi plus dyj. So plus dzk. If you take dot product of this, we'll get this inside term. Okay, if you take the dot product of f dot dr, this completely will get what here, this complete inside term. You can cross check. Now once we got this, f vector f, because to find curl of f we needed a vector f. Now to evaluate the Stokes theorem of the right hand side, means this left hand side is already, it is compare, it is same. So for right hand side we need vector f. Just now we have generated that. So with the help of this vector f, we'll see to evaluate the Stokes theorem of right hand side, that is curl of vector f, that is del cross vector f, which is determinant I j k dou by dou x, dou by dou y, dou by dou z. So coefficient of I is xy, coefficient of j is what here, xy square, coefficient of k is not there, 0. Now we need to simplify this determinant, which is I times dou by dou y of 0 is 0, formula minus dou by dou z of xy square, because here no z term, so it is constant. So partial differentiation of xy square with respect to z is 0, minus j times dou by dou x of 0 is 0, formula minus dou by dou z of xy, which is again constant, with respect to 0 it is 0, with respect to z it is 0, plus k times dou by dou x of xy square, because it is having x term. So dou by dou x of xy square will become y square, formula minus dou by dou y of xy will become what here, with respect to y we need to differentiate this xy partially, it will become x. So therefore now, which is nothing but del cross vector f is equal to 0 time I minus or plus 0 term j plus y square minus x of k. But in the formula we have a dot n cap ds. We'll make ready that also. So n cap ds is nothing but it is dy dz of I plus dx dz of j plus dx dy of k. So therefore dot product of these two, that is del cross vector f dot n cap ds will be, because take the dot product of these two, 0 I, you multiply I with I, j with j, k with k, so 0 I into this, it will become 0, leave it, 0 j into this, again 0, plus into plus is plus, leave it, y square minus x into dx dy, y square minus x into dx dy, and k dot k is 1, leave it. So we got the integral function which we can integrate easily. But before integrating, we should see that both the integral limits. Now we'll see using the condition. So this points what they have given, this is a square in the xy plane they have said, so vertices they have given, we'll draw the diagram and we'll see the limits for the integration. So diagram, the points are almost I will rewrite again once again the points are 1 comma 0, minus 1 comma 0, 0 comma 1, 0 comma minus 1. So diagram axis, because positive negative values are there, so you take both the axis, y, y dash, this is 0. So I will, in general I will take 1 here, this is 1, this is minus 1, this is also minus 1. So first point 1 comma 0 means x is 1, y is 0, point will come here. Minus 1 comma 0, x is minus 1 and y is 0, point will come here. Then x is 0, y is 1, x is 0, y is 1, point will come here. And x is 0 will come here, y is minus 1, point will come here. If you join, you will find a rectangle, square on the xy plane. So now you can see here the limits. So if we consider a horizontal line, x varies from minus 1 to plus 1 and y varies from minus 1 to plus 1. So therefore the Stokes theorem will become integration over vector f dot dr. I am writing once again, that is double integration over the surface f, vector f dot n cap ds. So f dot dr is nothing but the given integral. It is integration of xy into dx plus xy square into dy, which is equal to double integration over surface s del cross vector f dot n cap ds, which one already we have calculated. It is it is bracket of y square minus x of dx dy. So we'll apply here the limits. So if I take initial line, so x varies from minus 1 to plus 1, minus 1 to plus 1, and y, so on this you take vertical. So vertical line means y varies from minus 1 to plus 1. Of y square minus x. So we are going to integrate with respect to y, means write first dy then dx. Now integration, be careful. So integrate minus 1 to plus 1. So integration of y square with respect to y is what here? Y cube by 3 minus integration of x with respect to y is, it will become xy. Limit from minus 1 to plus 1. You need to replace the value of y as 1 and minus 1 into dx, which is equal to integration minus 1 to plus 1. Apply 1 cube is 1 upon 3 minus x into 1 is x. This is upper limit minus lower limit. Minus 1 cube will become minus 1 by 3 minus x into minus 1 will become what here? Minus x. That minus into this will become plus x into dx. So once, so we'll go for the simplification. Integration minus 1 to plus 1 open the bracket, 1 by 3 minus x minus minus plus 1 by 3 minus into plus is minus x of dx, which is equal to minus 1 to plus 1, 1 by 3, 1 by 3 will become 2 by 3 minus x will become minus 2x into dx. We'll integrate this finally. So what happens, we'll see 2 by 3 of dx is 2x upon 3 minus 2 is a constant. Integration of x is what here, x square by 2. Limit from minus 1 to plus 1, this 2 and 2 cancels. So therefore apply upper limit, 2 into x value is 1, so 2 into 1 is 2, 2 divided by 3 upper limit minus x square, value of x is 1, so 1 square is 1 itself, minus lower limit minus 1, x will be replaced by minus 1, so 2 into minus 1 will be minus 2 by 3 minus, so minus 1 square is plus only 1. So on simplification we'll get what here, 2 by 3 minus 1 minus minus plus 2 by 3 minus into plus is minus minus is plus 1. So minus 1 plus 1 cancels. So 2 by 3 plus 2 by 3, it will become 4 by 3. So therefore I can conclude here. So integration of xy dx plus xy square dy will be 4 upon 3 using Stokes theorem.